Hi, today I'll be teaching you how to factorize expressions by using the difference of two squares. So the key concept to keep in mind is that you should always look for the number in an expression that is a perfect square. So what is a perfect square? Here are just a few: 1, 4, 9, and 16. Notice anything? 1 is the same as 1 squared, 4 is the same as 2 squared, 9 is the same as 3 squared, and 16 is the same as 4 squared. So all of these numbers are simply numbers that can be square rooted and they'll give a whole number, okay? Alright, so with that knowledge, any expression that's the difference of two squares will take this form: x squared minus y squared. And it can be rewritten in this way: x minus y times x plus y. Now let's multiply that out just to prove that it's equal. X times x will give us x squared. X times y will give us xy. Minus y times x will give us minus xy. And minus y times y will give us minus y squared. And notice that in this case we have plus xy and we have minus xy. So those are just going to cancel out. It's going to be 0. And what we're left with is x squared minus y squared. So the original term. So we know that this right here is equal to this. Okay, so now let's take an actual example. X squared minus 4. How do you factorize this? We can tell right away that 4 is a perfect square, right? Because 2 squared is equal to 4. So that way we know that we will rewrite it as x minus 2 times x plus 2. Let's multiply that out just to see that it's equal to x squared minus 4. So x times x is x squared, 2 times x is plus 2x, minus 2 times x is minus 2x, and minus 2 times 2 is minus 4. So once again, the two middle terms will always cancel out and just give 0. And in that way, we'll be left with x squared minus 4. So it's equal. Okay, let's try one more difficult example. 16x squared minus 36. So this is a bit different, mainly because the numbers have gotten bigger, right? So these are bigger, and also we have a coefficient before the x. So we haven't talked about that before, right? Before it was always x squared minus something. So now that we have a number, but we can still see that this number here is still a perfect square, because 16, if you recall, is equal to 4 squared. And x squared is equal to x squared, right? And the root of x squared is x. And the same here. 36 is a perfect square because the root of 36 is equal to 6. So now let's rewrite that again. Since we've gotten the root of 16x squared, it's 4x, right? It's the two square rooted parts of it, so 4x. And 36, it will be root as 6, so 4x minus 6 times 4x plus 6. So now let's just multiply that out to prove that it's the same. 4x times 4x will be equal to 16x squared. 4x times 6 is 24x. Minus 6 times 4x is minus 24x. And minus 6 times 6 is minus 36. Okay, so there's a pattern developing here. The middle terms always cancel out to give 0, right? And we're left with 16x squared minus 36. So we know that we properly factorized it. So that's good. Okay, so let's try one last example. X squared minus 9y squared. Okay, now we have two variables, right? We have x and we have y. But don't panic, because we can use the same thing that we've been using before. So the square root of x squared will give us x, right? We already know that. And now here we have 9y squared. Notice that 9 is a perfect square, because 3 squared is equal to 9, and y squared is also a perfect square, because you're simply squaring y. And so when you find the root of 9y squared, you get 3y squared, because the 3 when it's squared is 9, and y when squared is y squared, so it's 9y squared. So let's rewrite that once more. So we'll get x minus 3y times x plus 3y. So now let's multiply that to see that it works. X times x is x squared. 3y times x is plus 3xy. Minus 3y times x is minus 3xy. And minus 3y times 3y will give us minus 9y squared. The middle terms cancel out, and what we're left with is x squared minus 9y squared. So remember, always look for the number that's a perfect square, and you'll be able to factorize the expression.